Hey everyone, welcome back to part 2 of our series on SolidWorks equation. Today we are diving deeper. This time we are taking on helical gear as our example. We will show you how to design the entire gear step by step using equation. No more manual edits, no more repetitive work. Just change a single value and watch the whole model updates automatically. It's smart, it's fast, and it's the real power of parametric design in action. Let's start. First of all, let's define some global variable to drive the other dimension during the modeling process. To do so, activate the equation option. The equations dialog box appears. Now, in global variable section, we need to define some important parameters. Like here I'm creating the helical gear. So far, we know that by defining the module and number of teeth as the global variable, we can create the other relations like pitch diameter of the gear, module times number of teeth. Outer diameter is module times number of teeth plus 2, and the depth below the pitch circle is 1.25 times the module. So in this, using these global variable, we can easily define the necessary relations. Now, in global variable section, enter the module, then press tab key and enter the module value, let's say 2 mm. Now, enter the number of teeth and then press tab key and enter the teeth value, 45 in this case. Once you have entered the global variables, then click on the OK. Now, we have defined all the necessary variables. Let's start with our design.
Now, let's create the base drawing for our gear. To do so, start creating the sketch on front plane by selecting it and choosing the sketch and drawing the circle. The pitch diameter is one of the most important features of the gear. It's defined when it defines where two gears interact with each other. Now, let's drive this with dimension. You can calculate the pitch diameter manually, but here we will be using the equations. To insert the equation, we need to add equal sign as the prefix. As you enter the equal sign, we have three options: global variables, function, and file properties. Now, let's select the global variable according to your requirement. Like for pitch diameter, we know that it's module times number of teeth. Just make sure to keep the space around them to keep the syntax correct. Once done, then press the green check mark to validate your equation and press OK. Now, we can observe that the diameter changed
90 mm
and the summation sign is added as the prefix, which defines the dimension is driven by equations. Now, let's create another circle for the outside diameter and apply dimension to it. Here, again, we will use equal sign as the prefix to activate the equations. Now, just enter the global variables. Like we know the outside diameter of gear is module times number of teeth plus 2. After entering, press the green check mark to validate the equation. Now, we can observe that the outside diameter is changed
94 mm.
Similarly, let's move on creating the inside diameter of the gear. To do so, again create the circle and apply dimension to it. This time, for inner diameter, we will be using relation. That is, the distance of inner diameter from the pitch circle is 1.2 times the module. Then click on the green check to validate the equation. Now we have created the base sketch for our gear. Let's extrude it. As we can observe that our sketch has many profiles, the SolidWorks is unable to find which one to extrude. So, using sketch contour option, we can select the desired profile or multiple profile at once to extrude. Here, I am choosing the outer circle. Then, choose the mid-plane extrusion type. This keeps the front plane at the center of your drawing and extrude it to 30 mm. Once done, after this we will be creating the sketch for our tooth profile on front plane. Now, let's start with center line at the middle, like this. Because the tooth profile is symmetric, so it will be helpful for mirroring and applying the other relations. Now, here we are going to create the sketch for our cut between two consecutive tooths. So I will be starting with the 3-point arc. Simply draw the arc like this. And now I need same arc on the other side of the center line. So let's mirror it. Activate the mirror tool and then select the arc. Right click to select the mirror about and then select the center line. After that, click on the OK button. The mirror of the arc is created. Here we need the base circle to define the depth of the cut. So I'm using the inner circle that we previously draw. Turn on the sketch we have created using feature tree and then use convert entities. We will be reusing it. Once you have created, after this, just drag the end of the arc and snap to the circle like this. Also, we don't need the full circle, so trim the remaining part using trim tool. Then I want that the cut is bit outside the model. So I will be offsetting the outer circle to a small distance. Let's do it to 2 mm approx. Then snap the start point of the arc to it by dragging it. Now we got the initial cut, but as you can observe that the blue lines in the sketch shows that it's underdefined. Now to make the sketch fully defined, let's add some more relations to it. The point where the pitch circle and the arc intersect is a critical point. Let's add relation to it. To do so, create a horizontal center line like this. I know that this line is horizontal by the yellow indication beside the cursor. Then select the endpoint, press and hold the Control key, and then select the pitch circle and the arc, and apply intersect relation to it. In a similar way, apply relation on the other side like this. The point is that this arc needs to be tangent such that it's coming out from the center point. To do this, create another center line starting from the center point and then
add tangent relationship by selecting both the arcs and center line. Once done, now we need to define the pressure angle. This point is important. It is a point where the adjacent tooth engage with the tooth on other gear. For this, let's create one more center line starting from this center line. And apply tangent relation to it with the arc. Also, make sure that this center line is coincident with this point. Then we can add the pressure angle. Like in this case, let's say 20 degrees. After defining the pressure angle, we can observe that some more information is missing to define the sketch. For that, let's create another center line. This line defines where the center of the adjacent tooth to this cut resides. So for the distance between this, we will be using the equation and apply the simple relation. That is 180 divided by number of teeth, because we only need the halfway of the tooth. After applying the relation, now we need to set the width of the cut equal to the width of the tooth. For that, draw the center line and apply perpendicular relation to it. Also, after applying perpendicular relation, apply the equal relation to the center line with previously created horizontal center line. As soon you do this, now our sketch is fully defined. Now, to create the helical gear, we need to do some more stuff. Activate the sketch by selecting the top plane and then create the center line to define the helix angle like this. Then create the midpoint relationship with the origin. This ensures that the midpoint always passes through the origin and the endpoint always stays symmetric. Now apply the dimension. I have kept my origin at the center of the part, so I can use the right plane to apply the dimension. In this case, let's say 10 degrees. Now, if I observe, our sketch is at origin and we need it on the surface. For this, we will be using projected curve. In projected curve, make sure the sketch on faces radio button is selected. Now select the sketch and then select the face and click on the OK. After this, we need the sketch on front and back. For that, let's use derived sketch option. In some of the videos, you have observed at this point, people prefer twisting geometry option. But I will be using derived sketch here. Pre-select the sketch and the face you want it to be. And then go to the insert section and select the derived sketch option. Doing this, the sketch gets copied at the selected face. Now, apply the coincident relation with the center to make its axis fix like this. Once done, similarly create the other derived sketch on the other side. Then select the projected curve and press and hold the Control key and select the common point on the sketch. After that, apply the Pierce relationship to it. Similarly, do this with the other sketch. To create the cut profile, now all we need is to create the lofted cut by selecting profile one after another and then click OK. And that's it. We have created the cut for our helical gear. After creating the cut, let's apply fillet to it. Here, we will use equation to define the fillet radius, that is equals to module times 0.2. And then click OK. Now, heading to the final part, we will create the circular pattern. Select the cut and the fillet. And for pattern direction, we will choose this face. And enter the equation here for number of teeth. Then press OK and done. Now, one of the great things that we have done is use the equation. Now let's say if we want the gear of different sizes, then we can simply change the module number or the number of teeth. Like let's change the module value to 1.5 mm and click OK. You will observe that the gear parameters are changed. And this way, we create the helical gear using equations. The helical gear was just an example. Using equations, you can save hours of rework and automate your most of the workflow. And that was all for this video. See you soon with another amazing topic.